Find the minimum number of cells required to produce a current of maximum of 1.5 ampere. It means current produces I max is equal to 1.5 volt, 1.5 ampere, sorry, it's ampere through a resistor of, that means external resistance is equal to 30 ohm. And minimum number of cells required to produce a current through a resistance of 30 ohm. And the EMF of each cell is 1.5 volt and internal resistance of each cell is equal to 1 ohm. It means we have to find out, this is the mixed combination is giving a maximum current of 1.5 ampere with identical cells of each EMF 1.5 volt and R is equal to 1 ohm. So total number of cells we have to find out for the mixed combination. As it is, we know for mixed combination, current is given by M into N into EMF of one single battery into M into R into N into R, where M is equal to number of rows and N is equal to number of cells in a row. So for I is equal to I maximum, the condition is M into R, M is equal to N into R. M into N is equal to N into R. So here it is given M. We have to find out M. For I max, we have M into M into R. R is given 30 is equal to N into internal resistance, this much. That is N is equal to 30 M. M is equal to 30 M. And also we have made this one, I is equal to M N epsilon naught divided by MR in place of NR. In place of NR, we can write MR plus M into R, because both are equal, so this can be replaced by this one. So this is equal to M into N into epsilon naught divided by 2M into R. This get cancelled, is equal to epsilon naught by 2 into N is equal to I. So I is equal to I max. This is for I maximum. For maximum. So what is I maximum is equal to 1.5. 1.5 is equal to EMF is also is equal to 1.5 divided by 2, and N also can be N. So this cancels. Therefore N is equal to 2. It means number of cells 50N or N can be replaced by 30M, because here N is equal to 30M, means 30. Therefore epsilon naught is equal to 1.5, and to N into, we have to have M into N to MR. In this numerical, find minimum number of cells required to produce a current, that is I max of 1 ampere. See, it is given maximum current is produced is I maximum produced is equal to 1.5 ampere through a resistance, that is external resistance of 30 ohm, The EMF of each cell is, the EMF of single cell is equal to 1.5 volt and internal resistance is equal to 1 ohm. So this is the given data. Current is producing, it is producing maximum current. It is a combination, it is a mixed combination. Mixed combination means it will have n cells in series with m rows. So m is equal to number of rows of the mixed combination, n is equal to number of cells in a row. So according to the condition for I can be given is equal to m into n into epsilon is equal to m into r plus n into r. This is the general expression for the current. If for I is equal to, for maximum current, that condition m into r is equal to n into r. M into r, n into r. This is already we have proved in the previous chapter, previous videos. In the previous, so we can write I maximum is equal to m into n into epsilon naught, epsilon, that is EMF of a single battery, epsilon into mr, since for nr, in place of nr we can write mr plus mr. Or we can write this is equal to m into n into epsilon naught divided by 2 into m into r. This we can cancel. Therefore, I max is equal to n epsilon by 2 into r. This is the condition. Or we can write in another way also. M epsilon naught 2 by r. This already we have met this condition. So I max, this is, so now I max, what is I max? I max is equal to 1.5 I max and n is equal to, we do not know, n into EMF of this one is equal to 3.2, EMF is equal to 3.2 divided by 2 into 1 by 30, where r is equal to the external resistance. R is equal to external resistance is equal to 30 ohm. These all data given. So now this can be 1.5 can be written as 3 by 2 is equal to n into 3 by 2 into 1 by 30. It can be written as 1 into 1 by divided by 2. This we have forgotten to write. N by 2 into epsilon naught is 1.5 by 2. 1.5 by 2 into this is equal to 1 by 5. I max is equal to n. N is n divided by 2. N divided by 2. Epsilon naught is equal to, that EMF is equal to 1.5. It is written as 3 by 2 and divided by 1 by r. R is equal to 30. 1 by r is 30. So this and this we can cancel. R n by 2. This is this and this we can cancel. Our n is equal to 2 into 30 is equal to 60. And m, what about m? See here we have written m into n. What is m into n? We can have the relation m into n. M into n, m into r, from this relation m into r. What is m into r? This is 30. R is equal to 30. External resistance is equal to n into r. That's internal resistance is equal to 1. Therefore, m is equal to 30m. N is equal to 30m. N is equal to 30m. And we got n. 60 is equal to 30 into m. Because n is equal to 60. N is equal to 60. Or m is equal to 2. That means what? M is equal to 2 and n is equal to 60. It means in one single row there are 60 identical cells and there are 2 rows. That is, first row, there are 60 in series and there are 2 such rows. Two such rows connected with an external resistance R. There are number of rows is equal to 60 and there are 2 rows.